Welcome back, students. Let's resume. Now let's go through some advanced examples on integration by substitution. This problem, and even worse, this problem. There are similar types of problems, and those problems are associated to this step here. After substitution number 2, we get a different integral by a different character, but sometimes that's not complete, and you have to go back to the original substitution and work it out. Well, in this case, the inside function is this, and you have to substitute dx. These two are straightforward. So let's go with y equals 1 plus x squared. Oops. Sorry about the typo. Okay, all right, that's the inside. The derivative is 2x dx, and consequently, we can solve for dx as 1 over 2x dy. And let's go ahead and do the substitution. So this is y, and this is going to be substituted by 1 over 2x dy. And then we have x and x cubed here, so we'll have a simplification like this: 1/2 x squared and square root of y dy. So this 2 came from this 2 in denominator, and this x down here cancels out with x cubed, and we get x squared. And if we have square root of y dy, everything is good, but there's a problem. I still have x expression here, so this y integral cannot be done yet. This is not a y integral, so we cannot finish this computation. What further technique do I need here? Well, we have to go back to the original substitution. Y is 1 plus x squared. Therefore, x squared is y minus 1. Do you see that? Here, this one is y minus 1. Do you see from here? Y is 1 plus x squared. From here, x squared is y minus 1. And this one went in right here, x squared, so that we have y1 minus 1 here. And what's left is now completely a y integral, so we can do our computation here. And that's the integral, let's see, 1/2, and then distribute y. Then I'm going to get y to the 3/2 power, and then y to the 1/2 power. Looks like that's what I'm going to get. I can distribute 1/2 as well, so let's do it like that. Okay, like this. And then if you completely integrate computation, let's see. 1/2 and increasing the power by 1, we have 5/2 power. So we need 2/5 here. 1/2 was before, and this is 3/2 power, and times 2/3. That'll finish the antiderivative computation. Let's go to the final answer. 1/2 times 2/5, so 1/5. And then what is y? In plus x squared and 5/2 power. Next, 1/2 times 2/3, so 1/3 plus x squared to the 3/2 power. And finally, that'll complete the problem. So here's the answer key I prepared in my notebook. Same as before, and then same substitution. And then the key is x squared. And then x squared is, as a matter of fact, the same as y minus 1. And then break up parentheses, antiderivative term by term, the final answer, exactly the same as what we just did. Let's do this one more time. Again, similar idea. It's clear that this is the inside, and then we have to substitute that one as well. So, we take u as 1 plus x squared. Previously I took y, maybe different character this time. Du is 2x dx. Therefore, dx is 1 over 2x du. So that's the original substitution, red. And this is dx substitution, blue. So far so good. And then let's get the entire integral expression here. So this is u, and this one is 1 over 2x du. So after simplification, one over 2, and then x cubed, x squared. So x squared left, and then 1 over square root of u, but I prefer the power form, so let's rewrite like this. Okay, it's going okay. Even though this is not a complete u integral, this is actually going okay, because this x squared is u minus 1. You see, flip this one to the other side. So this integral is integral of, oops, sorry about that, 1/2 and u minus 1 and u to the negative 1/2 power du. Okay, so far so good. And then let's break up. 1/2 u times u to negative 1/2 power. So positive 1/2 power. Distributing 1/2 and then also distributing this u to the negative 1/2 power. Looks like that's what we have here. And then we can calculate the antiderivative term by term. 1/2 was there before. Oh, sorry about that. 1/2 was there before. And then add 1 to the power, 3/2, and then we have to divide. Negative 1/2 was there before, and add 1 to the power, and then we have to divide. All done except the final substitution. So u is 1 plus x squared. So this one, let's see, 1/2, 2/3, so 1/3, 1 plus x squared, 3/2 power. And then 1/2 times u, so you have just 1. That's going to complete the problem. So how do you handle this kind of integral? If you have some residual x to whatever term left, go back to the original substitution and re-express it in terms of u. If this had been second power, okay, great. But if the residual here had been some 12th power or something like that, then this would have been far more complicated. Yes, you can complete that integral if you want to, but we have to pay the price. Okay, that's the final type of indefinite integrals by substitution I prepared here. There are many more types, of course, but we have only so much time that we can spend for class, so that'll have to do. In the next section, we are going to talk about indefinite integrals by substitutions.